So we're going to look at here at how the Earth's atmosphere was first formed and how it has evolved since the Earth was formed 4.5 billion years ago. So the Sun exploded in its formation at the very start of the Earth's existence 4.5 billion years ago, and in that explosion, atoms and elements were sent out into space. The lighter elements, the gases, if you like, went further, so the planets furthest away from the Sun, the solar system, the gas giants, Jupiter, Saturn, Uranus, Neptune. The Earth, about a little way out, not the closest. So we have a good mix of elements, some heavy, some light, and that's how the Earth was formed. These elements came together and formed the Earth. Now the early Earth, the very first Earth, 4.5 billion years ago, extremely hot. Okay, molten, if you like, molten ball. So extremely hot. So I'm just going to draw a thermometer here, just to get the idea that it's hot. And I even invested in a red pen for this video. I've pushed the boat out. So very, very hot. The thermometer, the mercury in the thermometer, if you like, red hot. Okay, now when the Earth was first formed, there was no atmosphere. Okay, and that really is the start of the Earth 4.5 billion years ago, 4,500 million years ago. Okay, now life starts to get a bit interesting. So it's cooled down just a tiny bit. Still very, very hot. Okay, so we've still got our Earth here. And it's still extremely hot. So let's have that thermometer in here again. Now, but we now start to have a change. It's cooled down just a little bit. So the outer crust of the Earth is cooled enough to solidify. So we have a solid outer crust. Okay, the Earth. So cool down to maybe just a teeny tiny bit, but still extremely hot, hundreds of degrees hot. Okay, so whereas this was possibly liquid in the right at the beginning, that we've now got a crust on the outside of the Earth. But inside that Earth, there's all sorts of elements. There's gases and liquid, gases and solid, gases and metals, if you like, and the gas is dissolved in the liquid that's inside. And what we get forming on the outside of the Earth is this dissolved gas, and this dissolved gas wants to get out. We get volcanoes forming. Now, this obviously is not to scale, okay, because a volcano would be about 5 times the height of Everest if that was to scale. But out of these volcanoes came some of these gases that were trapped in the centre of the Earth here. Okay, now there's 2 gases that form the majority of the Earth's first atmosphere that came out of these volcanoes, that erupted out of these volcanoes: carbon dioxide and water. Now, because this is very, very hot, the water that's coming out hundreds of degrees is not water liquid, it's water gas, it's water vapour. Okay, so we've got carbon dioxide gas and water gas coming out of these volcanoes. And it's these volcanoes all over the Earth that form the Earth's first atmosphere, because until this point, on this first diagram when the Earth was first formed, there was no atmosphere. Now we're getting the atmosphere coming out of these volcanoes. So the volcanoes are the source of the Earth's first atmosphere. And the major gases, carbon dioxide and water. What gas might you expect to find that is missing? Well, oxygen, I suppose. You could say nitrogen as well, but let's highlight the absence of oxygen. We're not going to worry too much about nitrogen for this GCSE specification. Over time, the Earth cooled, meaning that the water vapour in the atmosphere condensed to form the ocean. So we need another Earth now. Now the Earth's obviously a fair distance from the Sun. Okay, so the Earth, the first Earth that formed was extremely hot because it was a result of explosion, and it cooled down a bit as these volcanoes gave these gases off to make the atmosphere. But it's far enough from the Sun that the Earth is still cooling, and it cools to roughly today's temperatures, which of course is much, much lower than hundreds of degrees as it was when we're talking about the Earth this time. So now we've got the Earth cooled, so the thermometer is now much lower. Okay, so that's the important thing here. The Earth has cooled. Okay, so when the Earth cools, and it cools to beneath 100 degrees, the water that is a gas in the atmosphere is now not going to stay as a gas in the atmosphere. So the boiling point of water is 100 degrees. So the Earth cooled. Now the important thing, below 100 degrees. Okay, here it's above 100 degrees, and that's why we've got the water gas. Now we've got below 100 degrees. So what happens? Well, if you had lived on the planet at this point, there's nothing living on the planet at this point. There's no life at all. If you had lived on the planet at this point, you would have seen rain, and rain like you've never believed before. Okay, rain like you've not experienced before. It rains so much all over the planet at this time. Okay. The oceans filled up. The oceans filled up. So, we end up with therefore with 5/6 of the Earth's crust covered in oceans. So we have the formations of the oceans. So oceans. Now the oceans, the deepest ocean, 7 kilometres deep, 7,000 metres deep. We've actually explored the surface of the moon more than we've explored the bottom of the deepest oceans. So the amount of rain coming out at this point must have just been tremendous. If you visit the Earth at this point, what would it look like? A bit rainy. Okay, you can add to that as you wish. Okay, so at that time, the water vapour in the atmosphere decreased. Okay, the water vapour in the atmosphere decreased. But we've now got these oceans. Now, I hasten to add, there was no boats there then, but let's just put a boat in so we know it's the ocean. Okay, so we've got these oceans. All right, and at the bottom of the ocean here. Right. Now, carbon dioxide is in the atmosphere. Okay, now carbon dioxide will dissolve in the water. Now you've got oceans, you've got something that would dissolve carbon dioxide. Coca-Cola, lemonade. These are fizzy because they've got carbon dioxide dissolved in them. Now carbon dioxide is quite soluble in water, so carbon dioxide in the atmosphere will dissolve in the oceans, and this is one of the things the climate change naysayers, those people who don't believe in climate change, a reason they state it's not a problem. They say, well, we add more carbon dioxide to the atmosphere, more of it will dissolve in the oceans. And it will dissolve in the oceans. Now, in today's oceans, we've got lots of sea creatures, shellfish and shells and things like that that will lock up carbon dioxide into their shells as carbon dioxide. So I'm drawing a little bit of a crabby thing here, a very bad crabby thing. Okay. All right. And the shell of that crab. Will lock up carbon dioxide dissolved into there as calcium carbonates. Okay, so the carbon dioxide dissolves in the sea. The seawater has carbon dioxide in it, which shellfish and crabs lock up. Now, when they happen to turn up their claws and for the last time and fall to the bottom of the ocean, those shells and shellfish and all those shelly remains can fall to the bottom and start to form sedimentary rock, and we end up with layers and layers of calcium carbonate sedimentary rock, and locked up as rocks at the bottom of the ocean as these get covered in sediment as they die. So the point is, the carbon dioxide can dissolve in the ocean and then get locked up in rocks. Okay, so we've now got a decrease in carbon dioxide as well. Right, what happened next on the Earth? Well. Oh, it's not a very circular Earth, isn't it? Next on the Earth, okay, you've now got water, and we've got sunlight, and we've got carbon dioxide dissolving in water. We've got the perfect conditions for the evolution of plant life. So we're now starting to get life evolving on the planet. So the first planets look nothing like this at all. Okay, but hopefully it helps you get the idea. Okay, we've got ourselves a nice plant there, nice flower. Okay, now. These flowers take in carbon dioxide into their leaves, and then they give out oxygen. So suddenly, the carbon dioxide is decreasing, and the oxygen is now being introduced to the atmosphere, oxygen increasing. So here is possibly the first pollutants on our planet, because oxygen wasn't in the original atmosphere. So these plants polluted our atmosphere. So, humans aren't the only things to pollute, obviously. Now the oxygen's here, it's a game changer. It changes everything. Because now you've got oxygen in the atmosphere, animals can evolve. Okay, and now animals evolve. And you then have animals obviously respiring. So the important point here is photosynthesis. Okay, plants take in carbon dioxide and give out oxygen. So, just quick recap. First atmosphere, okay, carbon dioxide and water from volcanoes. All right, the water reduced because the earth cooled and the rain formed the oceans. The oceans can now lock up carbon dioxide as carbonate rocks. Plants then evolved. They reduce the carbon dioxide still further, okay, and the plants give out oxygen. So carbon dioxide in the current atmosphere is about 0.04%, very, very low, because it's dissolved in the oceans and the plants have taken it in. Right, roughly today, now 4.5 billion years later, we have a roughly balanced atmosphere. I say roughly balanced. I'm going to draw a set of scales here, if you can see what we're doing. Sort of an old-fashioned set of scales which rely on balance. Okay, on the one side, okay, we've got CO2 increasing. We've got things that add CO2 to the environment. On the other side, we've got CO2 decreasing, things that take CO2, carbon dioxide, out of the environment. Now, these are in rough balance, but they're certainly not exact. So carbon dioxide increasing, well, humans. Okay, let's just deal with that one first. Humans, burning fossil fuels. That's the one that's on everybody's lips, I'm sure. Okay, coal, oil and gas give out carbon dioxide to the environment and are adding to it tremendously. It's not just that, of course. Respiration, that adds carbon dioxide to the environment. Any animal respiring. Okay. Volcanoes, so 1, humans, 2, respiration, 3, volcanoes. Volcanoes are still erupting and they're still giving out gases. So volcanoes add carbon dioxide to the environment. Now, let's put this one down. Deforestation. Deforestation does not add carbon dioxide to the environment. It just reduces the Earth's ability to get rid of it. So be careful with that. And I once saw an exam question that says, what is responsible for adding carbon dioxide to the environment? And every student that wrote deforestation, it was marked wrong. Okay, because deforestation doesn't add carbon dioxide. It just stops the Earth's ability to remove it. So what takes carbon dioxide out of the environment? Answer, photosynthesis. Okay, that is the main one. The Amazon jungle is described, the Amazon rainforest is described as the lungs of the planet because it can process so much carbon dioxide into oxygen. Photosynthesis, that is the main one. 2, dissolves in the oceans. And this is one of the issues with climate change. So as carbon dioxide dissolves in the oceans, if more of it dissolves in the oceans, that non-metal oxides, when they dissolve in water, are acidic. The pH of the oceans could change, and that's fascinating. What's meant by human activity? Burning fossil fuels, farming, deforestation, things like that. And there's a very basic introduction to how the atmosphere has evolved, and it gets questioned all the time at GCSE, so best learning.